Hi, my name is Joanne Thomas. I attend Grantham University, majoring in Bachelor's of Science in Electronic Engineering Technology. My capstone for course ET450 is Biometric Recognition Systems. That is Arduino and Fingerprint based. It is a tool for establishing confidence to the general public when dealing with fraudulent and identity theft. For example, at ATMs. It is an automated recognition of individuals who are known or unknown that belong to a certain group with certain rights. So fraud and identity theft can be a serious crime that can happen to anyone, anywhere, anytime. It can be considered a personal assault on you, your family, your bank account. They can charge thousands of dollars on your debit, your credit card, your daily life, and walk away with your hard-earned money freely. The reason for this electronic project was in 2016, my identity was stolen. I felt hardened, violated, that my privacy of my information could be taken. And I felt that this electronic circuit, can help me in that situation understand. Maybe not in the past, but in the future. So the significance of this project will serve as an extra security measure with biometric traits against previously collected data for the individual. This is a proposed solution to this situation to design a biometric recognition system prototype with coding to function and convert, store, match a fingerprint image without providing your PIN code, your password, personal identification that might be present, but with a simple image. So the advantage to proposed solution can be high quality, low cost effective, safe, and operable for the user and any developer. So the only user requirements for my coding and circuit for my project, the user will need biometric characteristics, information to be captured with a simple fingerprint. So there can be various changes to the fingerprint, but for example, the individual's age, enrollment of a different finger, identification for the individual, the environment. It is a simple low-cost fingerprint technology. So I'm going to show you a actual tour of the multi-sim simulation and phase of the beer boarding diagram. So here on the screen, So here I had to install an Arduino Uno Shield template to actually help with the design of my circuit. So each components of the Arduino Uno are divided. So here are the analog inputs. Here are the voltage and negative ground that are actually connected. And on this side, we have the digital inputs, pins. Here we have the 6x2 LCD that is connected to the digital input output. Here I had to design a circuit for the servo meter because multi-sim software did not have it. So the servo meter is, here with a 5.5 timer rated, resistors, capacitors, ground, and voltage supply. Over here, this is supposed to be the fingerprint sensor module that is connected. We have the LEDs, the green and the red, and then here are the push buttons. So this right here, this is the actual circuit for code A, which was the stakeholders' first design that I had proposed. The stakeholders and the interviewer user did not understand how to start the system. They found it was too complicated. So here's a picture. If you look closely, it says, please match the start system. So I'm gonna go ahead and switch those pictures of the first prototype. Here we have the LCD wires here connected to the Arduino. Then we have the LED that's lit green. And here we are measuring the resistor, which is a 2.98. So I will scroll down to the next image where I am measuring the across between the resistors acting as a voltage divider. And here is 2.34. Sorry. And then here I gave a second measurement and it was 2.31. So the usability testing was to take a cosmetic presentation and contact of accuracy and general usability. The goal was to ensure the user interface was comfortable and provide the user with consistent and appropriate access. Navigation through the system with the access keys. But in this design, the stakeholders felt that it was too much information to follow and requested to actually do away with the push buttons and the servo meter that acted as an opening closed gate. So I will show you on the next screen. Here, this is the actual coding for the my circuit. So I included the fingerprint sensor library because so it can help function. Then I had the LCD library added. Here we have the pins that's acting, and then we are going to give a demonstration after I show you the circuit for code B. Okay, so let me put the camera down. Okay, so right here we have the optical fingerprint sensor that is connected to the 5 volts and the ground. Here is the 16:2 LCD display that is displaying commands. So right now I left it on imaging converted because I did go through it. And then here's the wires. They are connected to the digital pins. So they're connected from 8, 9, 10, 11, 12, 13. And over here, pins 2 and 3 are connected to the optical module. So over here, we have the LED that's connected, so it's displaying that it is lit. So I'm going to give a measurement of the resistors, voltage dividers, acting as a voltage divider. So I'm going to go ahead and do that. Let me go ahead and put that closer. I apologize for me moving. So right now it's at 251. So it's going up and down, and the percentage error on the circuit from the first one to the second, code A to type A to type B is actually at very low percentage. So we are going to demonstrate on how the coding with the optical sensor works. Okay, so the first thing to do, I would start it on the screen. So I want to use my index finger first. So we're going to type in 1 on the screen, and then it's going to say I'm going to put send. So from there, it's saying enrolling ID1, enroll finger. So the optical sensor is going to turn on. I'm going to go ahead and pick up the optical sensor to show you that my index finger has been taken. So on the screen, the image says, taken, image converted, remove finger, ID1, place the same finger again. So my image has been converted without pins, passwords, any of that nature. So it's been stored and it's ready again for the next command. So let's go ahead and I'm going to show you that on the LCD, it's going to say image converted. Okay, so we're going to do the same function again. I want to enroll my middle finger as a ID2. So I'm going to go ahead and send the information. As the optical sensor turned on again, ready to take the information. Well, the image. So I am going to put my middle finger. It says image taken, converted, remove finger. So, and it says place the same finger again. So I'm going to show and demonstrate that if I'm going to place my index finger, and on the screen it says fingerprints did not match. So I'm going to try it again. Press 2, send, put my middle finger in, remove finger, ID2, place finger again, image taken, ID2 stored. So it is a simple function that the stakeholders were very pleased with, and the results actually were easier to understand. So that simply was how I did my circuit from the first one to the second one. It was easier for the stakeholders and interviewer users to use. So it was a simple image of a fingerprint without using a password, PIN numbers. So that was the idea. That was Arduino Uno and fingerprint sensor base. So the next thing is it will be a discussion of lessons learned. So the thing behind the coding and implementing the software, it was very hard to understand. So designing the proper circuit, it took me about 2 weeks to try to figure out how to do it. And it wasn't working. A servo meter was actually a DC motor that I received from the manufacturer. It was sent back. I had to get a servo meter to act as an open and close gate to act as a click for the user to use. But the user said that there was no purpose in the servo meter in actually converting the image. So I had to do away with that. And then the push buttons, I actually left them open for them to use, and the stakeholder decided that it was not functionable. So the testing prototype on tolerance was without overloading without actually using a relay. So I had to learn how to finalize the design and the coding and make everyone happy. So I had to create a bill of materials with the proper manufacturer ID numbers in order to obtain proper parts to actually finalize the design. So it was actually the plan schedule to the actual schedule was different. I had planned to do everything with code A in 2 weeks or a couple hours. It actually didn't go that way. I designed a code B just as a backup to have presented code B to actually seem to work faster and more convenient for all parties. So the ways to improve the design was actually to detect the problems on the push buttons on week 6 in code A. I had to provide an alternate circuit design with code B for the stakeholders. Improve it with actually colored wires that actually fit with it. understand how to troubleshoot the hardware within range without not, causing damage to the parts, because I was limited on budget. And then actually, provide screenshots for each stage, and then update the lessons document. That was pretty much what I had to do. The hardware defect was at a medium level with code A, and code B, it was low. I was able to complete the project within approval and learn the different testing phases. Code B actually worked better with the approved components, and I was able to prepare this video for you today, a presentation. I hope you enjoyed my circuit, and if you have any questions, enjoy your day.